So far, we have only discussed objects and effectively ignored their surroundings. When an object is thrown, we are not that interested what it is thrown through. When we discuss fields, though, the area through which they are moving becomes paramount. A field is an area around an object which exerts a force on other objects within that field. Objects have properties associated with them. Masses have gravity associated with them. Charges have electromagnetism associated with them, and quarks have strong nuclear force associated with them. Materials have properties associated with them. Force fields isolate each type of force around a material. Objects can have mass, as well as charge and nuclear forces associated with them. Fields only deal with one force at a time. Force fields can be thought of as topographical maps from geography. A map shows heights of geographical features from sea level. A hill can be shown as a series of concentric circles shrinking up to a peak. Similarly, a depression in a land can be seen as a series of concentric circles shrinking down to a trough. Each point on these circles or loops is the same height above sea level. The concentration of these loops tells us how steep the slope is. The initial and final value of the loops tells us whether this is a peak or a trough that these lines demonstrate. In our study of fields, we will limit ourselves to only two particles. One particle is at the centre of the field and generates the field, and the second is a particle with unit amount of the force we are studying and can move around the field freely. These fields are radial. All the properties of the field are determined by the particle at the centre of the field. The size of the charge or mass determines the nature of the field. Wherever the second probe particle is placed within the field determines the strength of the interaction between probe and central particle. The field has the same overall shape, with lines of equal force being at the same distance from the centre of the fields. Field lines for a field point in the direction of the force. They are straight lines that are parallel to each other. They radiate out or into the centre of the field, depending on the nature of the force. For attractive forces, the field lines point towards the centre of the field. For repulsive fields, the field lines point away from the centre of the field.